Welcome. My name's Kara Hollis, and I'm a Principal Technical Advisor at NEOS Geosolutions. Over the next few minutes, I'll be taking you through some of the exciting results of our Appalachian program, Phase 1 in Tioga County. Our Appalachian Basin Geoscience program is occurring in multiple phases. Phase 1 in Tioga County has been acquired, processed, and delivered, and is available for purchase. Phase 2, expanded into Venango County, has been acquired and is currently in processing. We're in discussions now with several customers to expand our program. We can expand into Ohio with the guidance of our customers and into Allegheny National Forest. What we are going to spend time on in this presentation is talking about the results of Phase 1. The goals of Phase 1 were to contribute to an environmental baseline by mapping oil and gas seeps, to map shallow geogas hazards, and to use our high-resolution magnetic data to find abandoned wellheads and pipelines, and use our multi-measurement interpretation methodology to then map the relative prospectivity of the Marcellus. Here we have a map of Tioga County. We acquired data at a basin scale over the entire county, and at the customer's request, also acquired an area of high-resolution data shown in the red box. One of the primary goals of this survey was to contribute to the environmental baseline by mapping oil seeps and gas plumes at the surface. Below you see the results from our hyperspectral sensor. Green dots are classified as oil, and pink dots are classified as methane gas. Hyperspectral technology uses the sun as the source. When the energy from the sun reaches the earth, it's both absorbed and reflected by the materials at the surface. Each unique material at the surface has its own reflection pattern. By mapping these reflection patterns, we can map features like geology, plant life, and oil seeps at the surface. NEOS hyperspectral technology provides high-resolution measurement of the spectral signatures at the surface of the Earth. Compared to Landsat, which only has 6 sample points, NEOS technology has over 600 sample points. Ground truthing is a very important step in order to calibrate the airborne measurements of oil and gas seeps. On the Tioga survey, NEOS had a 75% success rate of detecting oil and gas seeps from the air. Now the question becomes, how many of those gas seeps could be coming from abandoned wellheads? In order to find potential abandoned wellheads, we used our high-resolution magnetic data and then plotted the known culture over the magnetic spikes. You can see here that we've found farms, houses, and most importantly, when we cross-reference all of this known cultural data, we find that there are 43 anomalies that cannot be identified from records or from aerial photographs. These cultural anomalies may be abandoned wellheads. Now the question becomes, how many of these cultural anomalies line up with gas plumes previously detected by hyperspectral? By plotting the gas plumes from the hyperspectral data, we can see at least 4 coincident locations where an unidentified cultural anomaly lines up with a gas plume. These should be the first places an oil company would want to check and make sure that they don't have potentially leaky wells over their lease area. It's obvious that not all the seeps are man-made, so now it's time to start investigating the near-surface fault picture. These faults were interpreted on many derivatives of gravity and magnetic data, but are currently displayed on an RTP tilt derivative. What we want to do now is take these faults, plot them with a seep map and over resistivity data to see if they could be the culprits of our local seeps. What we see here is the near-surface fault map plotted with the seeps over shallow resistivity data. This shows good correlation between the seep map and the fault map, suggesting that the faults and natural microseepage is the culprit for most of the seepage in this particular area. Airborne EM measurements can be acquired by 2 different types of systems. First is a passive source system that uses magnetotelluric currents as the source. Second is an active system that utilizes an active EM transmitter. For either source type, you have a choice of recording domains, frequency or time, depending on your imaging requirements. There are many EM acquisition systems on the market, many of which are tuned for mining applications. The NEOS systems, however, are optimized for hydrocarbon exploration. Our active system is for shallow targets, 0 to 500 feet, and is primarily used to identify geohazards such as shallow gas and map water tables. Our passive system is for deep imaging up to 10,000 feet and is suitable for deeper geohazards and also reservoir level investigations. This is a resistivity voxel from the first 500 feet of subsurface. This depth-registered volume can be investigated to find aquifers and shallow geogas hazards. On this slide, what we can see on the lower right-hand side is the digital elevation model of the survey area. On the upper left-hand side, we are now slicing through that depth-registered resistivity voxel. In the shallowest section, we see freshwater dominant aquifers. Slicing down another couple hundred feet, we run into the saline water dominant section of the water table. Being able to map these aquifers and understand the fault systems around them is very important to oil and gas companies operating in these areas. So coming down another few hundred feet in the shallow subsurface, we now run into a gas-dominated zone. The client provided us 2 wells and associated logs so that we could verify that indeed there were gas shows in this interval. Being able to map these shallow gas deposits is vitally important for well planning and for safety. Now we can begin to investigate our full column resistivity data, which covers from 1,000 to 10,000 feet. This data was generated with cutting-edge acquisition and processing techniques, and we are very excited by the potential value it can bring in both unconventional reservoirs and conventional reservoirs. So to investigate the passive volume, we can create isosurfaces. This is a 60 ohm isosurface looking at the gas bodies from 1,000 feet down to 10,000 feet. You'll note that many of the seeps on the surface are lining up with lineaments in this volume. Those lineaments are faults. This is a 1,000 foot above sea level slice taken from the passive resistivity volume. Plotted over top, again, is our seep map. We can see how the seeps line up nicely with the edges of the gas body features. In a few slides, we'll see why this is so when we look at how the faulting is controlling the gas in the area. This is a resistivity slice from the Marcellus interval. Plotted on top in yellow are the locations of horizontal wells. The well symbol size directly relate to the production from that well. We see a nice correlation between hot spots on the resistivity and the better producers, and a nice correlation between cool spots on the resistivity and the poorer producers. While this is not a definitive drill here map, this is valuable input into the analysis of the unconventional reservoir, showing that gas may be present. An important part of understanding this complicated area is to integrate as many data sets as possible. We begin doing this by 2D modeling. The next set of slides references line 5KT14 shown below. This 2D model incorporates faulting information interpreted from various derivatives of magnetic data, with stratigraphy, interpreted from 2D seismic, and provides valuable information about the basement structure in the area. Seismic data can be overlain on our 2D models for validation of faulting and can be used to adjust interpretation as necessary. When we overlay a vertical slice from our deep resistivity volume on a line, it becomes clear why the seeps at the surface were lining up with the edges of our EM anomalies. The faulting is providing structural control and migration pathways for the deep gas into the shallow subsurface and the surface. So, how do we bring all this information together to help our clients drill better wells? In the case of unconventional reservoirs, we can use a series of attributes and geostatistical calculations to create sweet spot maps. The map that you see on the right side of this slide is the sweet spot map we created for Tioga. To create this map, we used attributes that gave us information about porosity permeability, reservoir thickness, and the presence of hydrocarbons. Again, you see plotted over top the locations of the horizontal wells with the symbol size correlating with production. You can see how much production varies in just a small area. In order to produce the Tioga sweet spot map via our predictive analytics methodology, we first had to choose the appropriate data sets to analyze. This was done by a cross-correlation technique combined with interpretive knowledge of geologically relevant attributes. Then we chose the training data set. In this case, we used the location of the best producing wells, averaged over the first few months of production, as the locations that we wanted to find analogs to. We started with over 100 data sets and wound up using about 20 to produce this map. The attributes we chose gave us information about structural context, reservoir plumbing, or porosity and permeability, attributes that gave us insights into the tank or reservoir size, and halo attributes, which are indirect hydrocarbon indicators. As an example, a plumbing attribute, like the first vertical derivative of the reduced-to-pole magnetic data, shows us areas that may be more likely to contain localized faulting and fracturing. This type of information, combined with hydrocarbon indicators and structural insights, allow us to provide useful information to optimize drilling locations in the Marcellus interval. If we zoom in on the sweet spot map, we can get an up-close view of how the variation in color relates to the variation in production. This type of map could be extremely helpful in planning future well locations and maximizing production. Thank you very much for your time and attention. Please let us know if you have any questions.